Hello and welcome to my video on linear regression using the TI-83 or the TI-84 family of calculators. Before we actually start the data analysis or modeling, I would like for you to turn the diagnostics plot on, and to do that, right here at the bottom in yellow or whatever color your calculator has is a catalog button. So let's go down here by pressing second catalog, and then we will scroll down to diagnostics on. Right here, diagnostic on, press enter, and press enter again. So now the diagnostics is turned on, and you do not have to do this ever again. Once this is done, you are completed. So now what I'd like to do is to discuss entering data into the calculator. The data that I would like to take a look at is in your textbook on page 120, and it is the number of cable television subscribers. To enter this data set, we will press the stat button, and then we will choose the edit. So we'll just press enter, and now what we will do is we will take a look. This is the statistics data input screen, and across the top here you should see columns L1, L2, L3, and they will actually go all the way over here to L6. We will primarily concern ourselves with columns L1 and L2. If your calculator is not displaying these columns, then at this time you need to press Stat and then choose Menu Option 5, Setup Editor, and then press Enter. And now when you press the Stat and then you go to Edit or Input the information, you should now see columns L1, L2, and L3. If you have any information in the columns, you can go ahead and delete this information by scrolling up to the column header and pressing Clear and then Enter, and this will delete all the information in the column in one step. So I'm going to clear out L2, and now what we'll do is we'll make it a practice and a procedure that every time we want to enter data in the calculator, we will always enter the X component of the ordered pair in L1 and the Y component of the ordered pair in L2. So let's go ahead and start entering in L1 the year values, and when we do have year data, we do a base year, and then it's going to be the number of years past the base year. So we do not use 1999, 2000, 2001, etc., but we will choose 1999 as a base year, and then we will enter the number of years past that base year. So 0, and then for 2000 it's 1, and then for 2001 it's 2 years past 1999, and so forth. So let's just go ahead and finish this up. Okay, so we'll just enter the digits 0 through 7, and then we'll come over here to L2. And in L2, we'll just enter in the Y component, so 76.4, 78.6, 81.5, 87.8, 88.4, 92.4, 94, and then finally 95. And double check your data just by scrolling up and making sure that the values that you entered for the Y are correct, and also make sure that the length of the two data sets are the same. Again, you're plotting ordered pairs, so if you have one bigger than the other, you will get an error message. So next, what I'd like to show you how to do is to create a scatter plot. To create a scatter plot, using the TI-83 or the TI-84 family, let's do a little bit of preliminary work. And again, we won't have to do this again, but right up here above the equation editor button is stat plot. So let's go second stat plot. And we, for our class, will always use just stat plot number 1. Notice that there are 3 stat plots, and then there's plots off. So let's press enter, and there are some options here for us. I'm not worried about if you, at this point in time, if you have the stat plot on or off. But what I'd like for you to do is to come down here to the type. So these are the different types of statistical plots that the calculator can perform. So there is a scatter plot with lines, histogram, 2 versions of a box and whisker plot, and a normal probability plot. So if you'll just arrow down to the very first one, make sure this one's highlighted and press enter. And then if you'll come down here, the X list, well, this is telling the calculator where the X component of our ordered pairs are located, and we put those into L1. If you'll notice down here above the number 1 key, there is a direct access to L1. If yours does not say L1, just go second 1, and it will now say L1. And then we can arrow down here to the Y list, so it's looking for the Y component of the ordered pairs. And again, these are in L2. If yours does not say L2, then just go second 2. And then down here for the mark, it doesn't matter which one you choose, the dot, the plus sign, or the box. I usually run with the box, but whatever you choose. But just an FYI, if you use the little dot here, it's kind of hard to see the scatter plot. So we are done with the setup for our scatter plot. So if we'll exit back to the home screen by going second quit. And now what we need to do is to go into our equation editor and make sure that there are no functions entered into the equation editor. And if there are, just clear them out. And for those of you that may have little kids that like to play with the calculator and stuff, you might want to scroll down, because I've seen this before where errors have come up, or maybe the calculator got turned on in a book bag or whatnot. Just kind of give a quick scroll and make sure that there are no other functions in here. Up here at the top, you'll see plot 1, plot 2, and plot 3. This is a direct access of turning the stat plot on. So whenever you see plot 1, plot 2, or plot 3 highlighted, and you're trying to graph functions, you may want to make sure that none of these are highlighted. You just arrow up and press enter. So in this case, all of our plots are turned off. But now if we want to take a look at our statistical plots, we have to turn one of these 3 on. And again, we are going to primarily work with plot 1. So I'm going to highlight plot 1 and press enter. So that's the second thing that we need to do. And now to actually plot the data, the easiest thing to do now is to press the zoom button and then scroll down here to menu option 9, zoom stat. So press enter, and then here is a scatter plot of our data. So now that we have our scatter plot, we can assess whether a linear regression is a valid tool to use. And all we're looking at really is the plume of the data here, and to see if there's an overall general linear trend in our data. And here we can visually assess that there does appear to be a linear trend. So now we are ready to actually perform a linear regression. Now we are ready to perform our scatter plot, our linear regression. The linear regression is performed by pressing the Stat button, and then arrow over here to the Calc menu. And in the Calc menu, we have menu option 4, and there is another one here, menu option 8. This one here you will use when you're in a statistics class. This one here you use in a college algebra class. They both actually do the same thing. The only difference is which coefficient is going to be your slope coefficient. So keeping consistency with our authors, let's choose menu option 4, linear regression, ax plus b, so this means that the a coefficient is going to be your slope coefficient and your b coefficient is going to be the y-intercept. The linear regression takes two parameters. It's looking for an x list and a y list separated by a comma, but by default L1 and L2 are automatically used when these are not supplied. So as long as your data, your x values is in L1 and your y values is in L2, you do not have to supply the lists to this built-in routine. So now all we have to do is press enter, and this comes back and it tells us the model is y equals ax plus b. So a is 2.863 and b is 76.741, and then we have our coefficient of determination and our coefficient of correlation down here. If you did not turn the diagnostics on, these two would not show up. So that's why we did that at the very beginning of our video. So we can come back now and say that we have a model of y equals 2.863x plus 76.74. Usually when we use our linear regression, we want to use this to make predictions, and we would like to go ahead and use the technology to assist us in making these predictions. So when we perform the linear regression, all we have to do is just augment one thing. So let's rerun the regression. So let's go Stat, Calc, and then Menu Option 4. But now what I'm going to do is I'm going to supply a y variable. So if I press vars, y vars, choose function, and then I'm going to choose the y1 variable. So what this is going to do is it's going to perform the linear regression, and then it's going to paste the regression equation into our equation editor into y1. So let's press enter. So again, we've got the same results as before, but now if we press the y equals button, notice that it pastes the regression equation right into our equation editor. And notice now if we just press the graph button, we can view our linear regression, our scatter plot, along with the regression equation line. So now we can use the linear regression to make predictions. So if we want to evaluate this function for an x value of 11, which is 11 years past 1999, which would be 2010, last year, then now all we have to do is go vars, y vars, enter, enter. That's kind of a shortcut to get to the y vars if you're using y1, and then open bracket 11, close, and press enter. So this tells us that 11 years past 1999, or in the year 2010, according to the model, 108 million people will be cable television subscribers. If we want to evaluate our linear regression equation for the year 5, then again we just go vars, y vars, enter, enter, open bracket 5, and then we come up with 91.06. So notice if we compare y1 at 5, this is called a fitted value of 91.06, and compare that to the actual value for x equals 5 of 92.4, we can see that this model is pretty darn close. And we can also see that our model to the data set is pretty darn close too. There's going to be a little bit of offness here, but it's pretty darn close. So I hope that this little tutorial will assist you in performing your data analysis or your model or curve fitting to datas.